fractions. Do we do an improper fraction? An improper fraction is a situation where the numerator is larger than the denominator. This means that the value of this fraction is greater than 1. Everybody see that?
So what is your definition again?
An improper fraction is when the numerator is larger than the denominator. This means that this is larger than 1. Could we break this down to 3 over 3 plus 1 over 3?
Yeah.
So that's 4/3, isn't it? We got 3/3 here, 1/3 here, add them together, we have 4/3. So this is greater than 1, isn't it? Because this equals 1. Go ahead. What a complex fraction. Complex fraction is where you have a fraction within a fraction.
Wait, what?
Here's the numerator. You've never seen that? You will see it in this class. Athena.
So how do you line it up? You like bring the 5 down.
Basically what this is saying is like you have 1/5. That's 1 out of 5. This is saying you have 1/3 of 1 of the 5.
No, okay. 1/3. I got it. Nope.
You want to
1/3
of
of
1?
1/3 of 1/5 by 5.
1/5, right?
Right.
Means you have 1 out of 5.
Correct.
1/3 says, 1/3 over 1/5 says, out of these 1, you have 1/3 of it.
Oh.
Okay.
You have a third of the 20%.
You have a third of 1, yeah, a third of 20%.
Oh, okay.
Yeah.
Okay, good job. That was good.
Now, it can also look like this, too. Right? It doesn't always have to be in the numerator, it could be in the denominator as well.
So how does it work out in the flip-flop? The same way?
We'll get into that later. Just right now, I just want you to identify what it is. All right, so we got a complex fraction, a fraction within a fraction. It could be like this, too. Okay, it could be like that. Hang in there, we'll get there. All right. But you're all ready to see this get erased.
Yes.
All right, how about a whole number? We have something like 3 over 3, 5 over 5, 6 over 3. When we evaluate this or simplify it, what is it going to go to? This goes to 1, this goes to 1, this will go to 2. All right? 3 goes into 6 2 times, that's a whole number. This value represents a whole number. The fractional part is the part that's in between the two wholes, or the two whole numbers. Let's go to converting.
Yeah.
First thing we're going to do, fraction to a decimal. Let's go like this, before I kill myself. Every fraction can be converted to a decimal. Every decimal can be converted to a fraction. Let's start out easy. We got a fraction, 1/2. How do we convert that to a decimal? Yeah, I know you know what it is, but how do we do it? Process.
You just bring it over and say
All right, 2 goes into 1 0 times. Remember, whenever you're writing a decimal, if there's no whole number here, always put a 0 in front of it. Reason being, especially true when we get into meds. See that 0.6? That can be easily confused with just 6. When you put a 0 here, now you know it's less than 1. So that's a practice that we're going to be doing a lot of. All right, so we put the 0 there in front of the decimal point because 2 doesn't go into 1, so we know this is less than 1. 2 goes into 10 how many times? Subtract away 0, it terminates. So 1/2 is equal to 0.5, bottom into top. Does that make sense?
It's like a silly question, but why did you put the second zero if you wasn't going to use it?
I just put a couple zeros there to get started.
But why? I feel better about that.
Okay,
Whole thing.
hey.
Thank you.
Whatever it takes.
So the answer is not .50, it's
It's the
0.5.
same thing.
0.5.
0.5.
That's the
Yes.
same as 0.50, right?
Yes. The zeros add nothing to it. I could add zeros from now to infinity. The value is the same. Well, the way I erased part of it. It's all the same.
And that'll still be 1/2.
That's still 1/2.
Okay.
Can we do one more?
Sure. Yes,
Do you always have to put a zero in front of the, if you put 0.5, is that wrong? Do you always put that zero there?
have to.
Okay.
Because they'll get 0.5 confused with just 5. Let's try this one. Let's change it to 3/4. All right, we're going to do 3/4. It's bottom to top. I'll only put 1 0 to start, just in case if I need more, I'll add them as I go.
Thank you.
All right. Does 4 go into 3?
No.
No, all right, so we know it's less than 1. That makes sense. Here's a good check, though. A lot of times the student will, remember, denominator, divisor, and the numerator goes inside. Now, if you ever got 3/4 and your value here is larger than, let's say, 1, you know you're doing something wrong, 1 or larger. You've got these two flipped. All right, 4 doesn't go into 3, 0. That's good. Makes sense because this fraction is less than 1, so our decimal has to be less than 1. If we had a 1 here, it would be 1.
Okay, you can put the zero now.
I'm not ready yet. I'm not ready. How many times does 4 go into 30?
7.
7 times. So this is 28. Subtract it away, I get 2. Now I'm ready for a
When
0.
we really needed the zero for the problem, you didn't put it.
Well, you got all nervous the last time. I don't want to make
Because we
this
didn't need it.
Drop down the 0. We got 20.
Okay. That's
4 goes into 20 how many times?
5.
5. Subtract away at 20, we get 0. This terminated out, so 3/4 is equal to 0.75. Make sense?
Yeah.
Okay.
That's pretty cool.
Back to a fraction. Yeah, this caused some people grief. All right, we used, let's say we had 1/2 was equal to 0.5, we have 3/4 was equal to 0.75, right? That's what I used. I'm going to use those for reference. Not only am I going to show you this, I'm going to teach you a couple of rules. Okay? So there's some rules here. All right, I got 0.5. I want to convert this back to a fraction. We already know what it is, right? It's 1/2. Rule part, step 1, division bar. Put a division bar there. Step 2, take the digits to the right of the decimal and put them in the numerator. So in this case, it's only 5. Okay. All right, first thing we did was we created a division bar. We took the digits to the right of the decimal. There's only 1. We put them directly into our numerator. Step 3. We're going to come over here. We're going to put a 1 in the denominator. It's always going to be 1. All right, we did step 3. Step 4. We're going to come over to the decimal. We're going to count the number of digits to the right. In this case, we have 1 digit. Therefore, we're going to put 1 0 in the denominator. Okay, so we're going to count the number of digits to the right. In this case, it's 1, and we're going to put that number of zeros in the denominator.
So if there was more than 1 to the right, you would put as many zeros as there are
Exactly.
numbers.
You're going to count the number of digits. Number 5.
Wait, can you add a number to it, like an extra zero, so I don't understand?
I'm going to do another example. Just get this one down for content first. Number 5 is simplify. All fractions must be in simplest form.
1/2.
Okay, now we look at this. One trick to simplifying, this ends in 5, this ends in 0. We know both terms are divisible by 5, so let's divide this by 5 and this by 5. We're going to get 1 over 2. Is that correct?
Yes.
Yes.
Can you read me number 4, because I cannot see it.
All right, number 4 says, we've already put a 1 in the denominator. Okay? So now, number 4, we count the number of digits to the right of the decimal. There's only 1 in this case. That is the number of zeros I'm going to add to the 1 in the denominator. So 1 decimal place here, 1 0 here.
I just can't read it.
Well, my writing's terrible. You guys
Well,
are...
there's a glare too.
All right, let's do 3/4. We already know it's 0.75, right? Now let's follow our sequence of the steps here and let's see if we can change this to a fraction. Step 1, easy. Put a division bar. Boom, it's done. Step 2, take the digits to the right of the decimal and put them in the numerator. There's 2 digits here to the right of the decimal. I'll put those directly in the numerator, 75. Go to the next step. Put a 1 in the denominator. Next step, count the digits to the right of the decimal and put that number of zeros in the denominator. So I come over here, I got 2 places to the right in my decimal. That means I got to add 2 zeros in my denominator. Now, the last step is simplify. Well, I look at this.
25.
This ends in 5, this ends in 0. I know they're both divisible by 5. If 5 works, these are rather large numbers. Let's try 25. Right? 5 times 5 is 25. So if I divide this by 25 and this by 25, it's going to equal 3 over 4. 25 goes into 75 3 times, 25 goes into 100 4 times. 3/4. That's good? All right, what else can we do? Every improper fraction can be changed to a mixed number. Every mixed number can be changed to an improper fraction. So let's take this down.
So to know which of the fraction is bigger than the other, you have to convert to decimal and vice versa.
I'm going to show you.
Now we show.
Dave, I'm going to show you some easy techniques. It's going to almost be a visual for about half. All right, mixed number to an improper fraction. Let's take a mixed number. We got 3 and 1/2. We got 3 and 1/2. Here's how we change it to an improper fraction. We're going to come over here. We're going to put a division bar. Remember, the denominator is always the same. That does not change. Whether it's a mixed number or an improper fraction. So let's put a 2 over here. Denominators are the same.
Wait, so the denominator, no matter what, is always going to stay the same?
Yeah, it's always going to stay the same when you're converting from a mixed number to a improper fraction. So now, we've got our denominator. Now we've got to figure out what our numerator is, right? Since this is a mixed number, we know this has to be greater than 2, right?
Yeah.
Makes sense. So it's going to be 3 times 2 plus 1.
7.
This equals 6 plus 1 is 7, so it's 7 over 2. So we took a mixed number, we changed it to an improper fraction. The way we did is we kept the denominator the same, we multiplied 3 times 2 and added 1. Let's do it visually. What this is saying is we're going to take 2 over 2 3 times. Right? That's this. Then we're going to add 1 over 2. Now when we're adding fractions, the denominator is always the same. Now let's add this up. 2, 4, 6, 7. 7 over 2. This is done using multiplication and addition. This is strictly addition. This represents the 3. Now,
Would you be able to go over the numerator portion of it one more time with the mixed fractions?
see how we have 2 over 2 plus 2 over 2 plus 2 over 2? Each one of these is equal to 1, right? It's saying 1 plus 1 plus 1. So we're saying we have 3 times 2, which is 6.